Yeah, perfect. All right, so the next talk is Julius Breuer. He is, I'm going to be in your personal space for a bit here.
Yeah, that's fine for me.
Julius studied mechanical engineering and computational engineering at TU Darmstadt and continued with a PhD at TU Darmstadt about mathematical optimization of ventilation systems. Welcome.
Yes, thank you. Can you all hear me? Yeah, sounds good. Okay, yeah. Compared to the talks we had so far, my talk is very much more applied. I think maybe it's a nice application because it's a bit off the usual application maybe. And I'm not a big team working on it. It's mostly me and some students working on it, so bear that in mind when you see it. Yes, I will talk a bit about the my topic basically, or what we are researching in our subgroup of the institute. As was said in the introduction, I'm working on the optimization of HVAC systems, and so we talked a lot about infrastructure today. This is like a totally different infrastructure than IT infrastructure, but yes, so in the beginning, it doesn't have anything to do with like DataLad or distributed systems. We are looking at water supply systems, HVAC systems, and process engineering systems. Is it okay with the sound? Yeah. It seems a bit off. Okay. And we are trying to optimize this. So we have certain needs, like fresh drinking water, pleasant room conditions, or we want to remove heat from process engineering. And what we are doing is we are basically looking at a certain system, like a ventilation system here. And the system has several components. Now you can only see the fans. We have some throttles in front of the rooms. We can also have, I don't know, silencers in front of the rooms. And we are doing some discrete mathematics to optimize this. And we're in the planning phase of a building, so we ask several questions, like which components should I buy? Where do I place the components? How do I connect them? And how can I operate them efficiently? And then I can optimize one system, but normally we optimize multiple systems. For example, we have multiple like different setups, multiple fans, more fans somewhere. We can have like one or more load cases. We have a lot of uncertainty, obviously, in the planning phase. There's a lot of things that are not known, like energy costs in the future, component costs, and we have different trade-offs. And in the end, this leads to thousands of optimization runs. But generally, like one optimization run will only produce some megabyte of data. So it's not a huge problem concerning the space, for example. Okay, but still this shows the need for research data management. And so ideally as an engineer, I'm not that much working like with IT. Like I'm programming, but I'm not really deep down in the IT as I guess most of you are. So for me, the optimal case would be I have an optimization problem, I have the data, I put it into some machine, I get the output, I have all the metadata stored, and everything is provenance and fair. That would be awesome, but this is not the case. So if you look at the standard approach, what engineers normally do, at least I'm talking about mechanical engineers, we copy some data and some model into one file or like some folder rather, then we solve the problem, we save the result, and we lose all the information about what we did and why we did it maybe. And yeah, that's not the optimal approach, so the question is, can we do better? And at our institute, we are working at the, I don't know, maybe some German people here know it, the Nationale Forschungsdateninfrastruktur, and this one is for the engineering sciences. So we are basically taking a lot of stuff from computer science to engineering science and try to like apply it here. Yes, so this is what other people at the institute are doing, and some people thought about a workflow that could work for system design, or generally that would be good for good scientific practice. So we have like a woolen thread, and in the end you can unroll it, and you have like all the persistent identifiers, and you can see, okay, I have a paper and there's like a figure in it, and then later I can see, okay, with which test rig, for example, was the data validated or something. And then everything is findable and accessible and also reusable in the best case. And then people at our institute sat down and had like an idea how to do it. You have like component databases, maybe building database in case of a building. Then you have simulation data, and like this is like MATLAB, but normally like Python file. Then we have some optimization settings. And the whole run here is basically we have one HDF5 file, and we put it through all the stages and just insert all the data in here into one run, and in the end we can save it in the server. This was a huge step actually for us, but there's obviously some advantages are I have no data loss because everything is in one file, and I can include metadata as its HDF file. But disadvantages are we started from scratch, so this was programmed by some student as well, not very efficiently probably. We have enormous redundancy. I think this is the major downside here. We have everything in every file. We have all the information that is super redundant. We don't have clear provenance, and the workflow is rather fixed in this setup. So the question was, can we do even better? And then one of the data stewards in our institute said, yeah, hey, Julius, maybe if you start your project, maybe you want to do some better stuff using DataLad. And that's how I got to use DataLad now. And the idea is very similar, actually. It looks pretty similar. I have component data in some databases on GitLab. I can merge the data, so I have 5 minutes left. Easy, okay. I can merge the data to have one real ventilation system, so building data, component data mixed together. Then I have models, so different optimization models. I can merge all together to instantiate a model, and then I have some optimization settings, maybe solve it with different solvers, and store the solutions, and maybe do some post-processing, like visualization. Okay, this is basically like the system before, but now with DataLad, I'm not only able to basically package everything into maybe sub-data sets and work with it, or work with the data I need, but I can even keep track of the individual steps and make sure that everything is provenant. And that's basically what we do. So I have multiple projects now for different tasks or different things I want to look at, maybe a project, like a paper or some study I want to do. Then everything is basically linked through sub-data sets, and this one data set controls and tracks everything. The advantages obviously are I have no redundancy, or very little redundancy. I have a decentralized setup, so currently it's mostly me working on it, but one could also imagine that there's maybe other companies or other people providing some component data, and one could work together here. Then I have a clear provenance and a liberal workflow. The disadvantages are probably also mostly because I come from engineering side, so the difficult setup, working with WSL, so Windows Subsystem Linux, is not super hard, but I need to find students who want to do the work, and then it's pretty hard actually, because students barely know Git. I mean, now they start to get to know it, but not too much. You need to know DataLad, and this makes it very hard for students actually to start with a program, and it's not easily Jupyter Notebook compatible. This is also, maybe a small downside in this side. And that was all I wanted to talk about. Thank you for your attention. Okay.
You have, there's 3 minutes if anyone has a question right now.
Basic question. You said that output, which is metadata, is stored in H5 so HDF5 file, right? Mm-hmm. And it's just metadata. Why not something like JSON, YAML?
You mean why we use HDF5?
Yeah, at the output level, where you said that it's just metadata about that run, I guess.
No, everything is in the HDF5 file.
Okay. So it's the entire output?
Yes, everything basically, yes.
Gotcha. Are there samples on GitHub or somewhere else to look at the results of this work?
You mean for the previous work? There was only HDF5 or the current work?
Oh, the current one with DataLad.
The current one, there is some results, but it's not there's metadata is still lacking a bit, and so it's a bit flimsy currently, I would say. Yeah.
Any other questions? All right.
You mentioned being involved in the NFDI for ING.
Yeah, I'm personally not involved, but a lot of people at the institute are.
Okay. Are they picking up a DataLad, or are they using DataLad within for any other purposes?
My colleague shakes his head. He knows better. So no.
Okay.
So some people know. So for example, our data steward, he knew that this was a thing, but I guess not a lot of people are at our institute. No one else is using it. So yeah, not really.
Okay. Thank you.
And we have time for probably one more. Oh, perfect. And then we'll go to the next speaker.
No.
Oh, it works.
No.
Back to that HDF5. Oh, right. So standards. Do you have a standard how to lay out those files in the file system so it's like easy to understand later on, like what kind of models were run, what parameterizations? That's one.
That's also a very good point. Like a schema or something, right?
Yeah.
Yes. The problem that is also kind of tackled in this NFDI for Inc. is that there is no real schemas or like standards for, especially for this kind of optimization problem where, like, I think on the engineering side, it's really lacking a lot of schemas. There's some, but I checked into it, but you have to start very early, like implementing your own stuff there. So yeah, it's really lacking a lot there.
And is there some kind of on top of that system which would provide you a summary, like, oh, you've done these optimizations, like this is what you've missed. So kind of to sit on top of those modelings, right, and provide you a summary what you haven't done, what was the average time, what was the best solution, you know? Which boils down to the schema of the results to some extent. But it's
So basically some post-processing of all the runs that exist, yeah. No, this is not existent currently, no, not.
so ample opportunities, ample opportunities.
Yeah, sure, yeah. If I would have like all my time to just work on the research data management, it would look much better, I guess, but yeah, the problem is I'm also like mostly working on the optimization stuff, so this is kind of a side project, but yeah, there's endless possibilities to make it much nicer.
You've probably heard about BITS standard, like brain imaging data standard, and it has nothing to do with optimizations, right, or duck, whatever, but it's about how to lay out files in the file system and which metadata you provide. That question about metadata and data being stored in a single HDF5 file, if it was BITS-inspired standard, there would have been a data file and then metadata about that result outside, which would be kind of domain agnostic. And that could be your step one to establish convention.
Okay, yeah, that's a good point, yeah. Maybe we can talk about it also later. Thank
I'm
you.
taking this now.
Okay. Okay. Thank you.